Hey, welcome to the Swift tutorial. And in this, we are going to talk about the comparison of two custom objects of class or a structure. So, uh, we have integers, we have doubles, we have strings, and we can easily compare them with double equals to, greater than, less than, less than equals to, not equals to, anything like that. So, we are not able to use these operators with our custom objects. Let's say I'm creating a class of student and I'm going to give a name and an ID. Okay, and just make a constructor which has a name and ID in it, and self dot name equals to name, self dot ID equals to ID. Okay, so I'll be making two objects, s1 student. Let's say the name is Rajan, the ID is 1, and s2. Let's say the name is Ram and ID is 2. Okay, so if I'm using s1 double equals to s2, and if I want to check the equality of the two operators, s1 double equals to s2, so it will not work probably, and will throw an error that the double equals to operator cannot be used with the student operands, because the student operand has nothing in it which can lead to a comparison. It has two different type properties and there is no way we can compare it. So for this we have three protocols available. We can use any of them, and with the help of them we can easily make our custom classes uh, which can easily make use of the binary operators. Okay, so let's start with equatable first. How we can use equatable and compare the two specific objects. So let us start with equatable. How equatable works. So let us conform our class with equatable and see what happens. Let us run it. So it's saying that the protocol equatable has the student does not conform to protocol equatable because we might have missed some function which needs a definition. So let us go into the equatable class, the protocol, sorry, and see what function it has. So it has a function double equals to. It's just like operator overloading. So basically we have to define the double equals to, what is actual definition of double equals to and what are the RHS and LHS values to be compared with. So let's define that as well. So I'm going to add the stub. So here I'm going to write this beneath the constructor. Okay, so I will be doing something like return LHS dot name double equals to RHS dot name and LHS dot ID equal to RHS dot ID. So it's saying that the name and ID are both compared with the two objects on the right hand side and the left hand side, and if and only if both the objects are similar of the two, both the properties of the objects are similar, then only it will return true, otherwise it will not. Now as soon as I described the double equals to operator, you can see the error goes away and I can easily compare the objects without any errors. Currently it's coming in else block. You can see, let's say s1 not equals to s2, and it will print definitely s1 not equals to s2 because s1 has Rajan as name and Ram as s2. In s2 has the Ram as name and s1 has ID 1 and s2 has ID 2. So let us make the name and the ID same just to make sure that our equal to operators work, double equals to operator work. So yes, it's working. The binary operator double equals to is working. So now we can compare the objects of my student class as well using the binary operator double equals to, which will yield a true or false result. So this means that I can also add S1 and S2 in a set, and before that I couldn't, because set is something which needs something to calculate whether the objects are same or different, right? So that should be conformed to equatable. Okay, so for the first part, equatable, we uh, did some experimenting and we are successfully through to the double equals to thing. We provided a definition and we use that double equals to operator with the two objects of student class. Fine. Now let us suppose I want to check the greater than and less than operator as well. So how can I make use of that? Suppose if S1 is greater than S2. Now if I run this, it will say we cannot apply the greater than operator, because equatable protocol only has a single function, double equals to. It doesn't have a greater than or less than or greater than equals to less than operator. So for that, instead of equatable, we will use comparable. So switching to comparable. And what is comparable? Comparable is nothing but a protocol which is again conforming a equatable protocol. So we have to keep this as well, because it's the need of equatable protocol, but comparable has its own stubs. Less than equals to, greater than, and greater than equals to. So now we have to define the operation for greater than and less than. So I will be just adding a protocol stub, and I will be just using that for less than operator, and we'll see the magic what happens. So let us make a less than operator, and in this case let us compare the two objects on the basis of id. Suppose if lhs.id is less than rhs.id, so your s1 is less than s2, so this will pass. So in this case s1 has id 1, and let us make the id 2 here irrespective of name, and let us print what happens. S1 is greater than S2, else so I overridden less than sign, so I will use this. S1 is less than S2, and in the else block S1 is greater than S2. For the time being, I will comment this code out. Fine. Now let us run the object. Okay, so it's printing that S1 is less than S2, which it should, because the ID of S1 is less than the ID of S2, and what I have written in the definition is the same. S1 is the LHS and S2 is the RHS, so it will succeed in a true, since 1, which is S1, the S1.id means 1 is less than S2.id, which is 2. So yes, the definition is working fine for less than also. Now let us implement greater than operator, whether it will work or not. So I think it will also work. You can see that S1 is, it's printing that S1 is greater than S2, but it should not actually, because S1 is less than S2. So what will happen here, since it's a else block and we are not handling any situation, so we have two methods here. So let us write the complete closure, the complete if else thing, to make sure whether the statements are fine. So first I'll write for equal to, then I write for, let's say, greater than. S1 is greater than S2, and finally I'll write else, and the third condition is S1 is less than S2. Okay, I'm going to remove this code and let me run this. So what happens? So S1 is less than S2, it comes, since the ID of S1 is less than S2. Let me decrease this and increase S2 S1. So it will come that S1 is greater than S2. So you can see that even the greater than check is also working. Now LHS means S1 has a ID 2 and S2 has a ID 1, and it is successfully working for the greater than check as well, since S1 should be greater since it has ID 2. So you can see that we have to implement just two operators, any of the two operators, not any of the, basically we have to implement equals to, double equals to, and we have to implement either the less than or the greater than, and it will automatically be functioning as per the for the other operators. Okay, so let us also write something like, let us comment all this and let us check for greater than or less than equals to as well. So S1 greater than equals to S2. So let me write that S1 is greater than equals to S2, else S1 is less than S2. So let us check for greater than equals to S2. It means that it will certainly pass with both the checks, greater than as well as equals to. So obviously we are first checking for greater than, since the ID of S1 is greater, LHS is greater. So yes, we are getting into it. Now let us make both the properties, the name is already common and the IDs should be the same as well, to check whether we are getting into this block as well. So again, yes, we are coming into this block. So this means that greater than equals to operator is also working fine. Let us change the values. So S2 will be now greater. So this check will fail and we will directly come to S1 is less than S2. So perfect. So by implementing just two operators, we have actually implemented 5 other operators, like less than equals to, greater than equals to, less than. So in total, we have implemented 5 operators. Obviously, we have also implemented the not equals to operator, S1 not equals to S2, and we can certainly check. I'm going to comment that and print S1 not equals to S2. So here it will print S1 not equals to S2 because they are not equal. Let us make them equal. So it is not printing anything. Basically in the else block it should be S1 double equals to S2 for the time being. I'm assuming that if it's not equal, then it's equal. Yes, they are equal. Okay, so by just using these operators, defining these operators, we have already defined automatically what? Less than equals to, greater than equals to, and not equals to. So it's so cool that just providing the definition of 2, we have provided the definition of 4 other operators as well. And now our class student will all the objects of the student class will use the Boolean operator and can perform the comparisons very easily. That's great. Now come to the third part, hashable. This is somewhat very interesting. So I'm going to delete everything. I will be keeping just the objects. Okay, and let's get rid of this less than operator as well. Now hashable. Okay, so hashable is what? Hashable is another protocol which is conforming to Equatable. So if it is conforming to Equatable, then we have to again provide a definition for double equals to, which we are doing. Okay, now what else hashable say? Hashable says that it provides a hash value which is an integer and nothing else. So it can be a very long integer, and this hash value is very helpful in knowing exactly whether the two instances are same or not. So you can see that this hash value which we used to write earlier is now deprecated, and instead they have provided a function, a hasher. So we will be implementing that function. So let us start with the function. So it's saying that it is not conforming to protocol hashable. The reason is that we are not implementing this function. So let us implement this function. Okay. Yes, and the error is gone. Now you can see that we have a student class which is conforming to hashable, and we have a double equals to function, because since hashable is conforming to equatable, and we need this definition, and we need a definition for this hash function as well. So for the time being, I am leaving this hash function empty, and now I'm going to print the hash value of both the objects s1 and s2, and let's see what happens. You can see the hash values are same. Now let us modify the object and make it 2 for the id of uh, s2 and also the name. So in that case also you can see the hash value is same. So how it is helpful? It's not doing anything, it's giving the same hash value again and again, because we haven't provided any definition to the hasher function here. So we have to provide the combine to the hasher for which properties which we are interested in comparing. So hash dot combine hasher dot combine and name dot hash value. If we are taking the name into the consideration, and id dot hash value. And now let us run the application. So you can see the hash values are different now. Let me make the id same and name different, and let me see what happens. Again the hash values are different. Let me make the name and id same for s1 and s2, and now you will see the hash values are exactly the same for both the objects. So this is the way how hash value works. You have to provide the combination here along with the hasher in which values you are interested. Now for example, I am commenting this id, and I'm changing this id to 10 for example, and I'm running. Then also it will provide the same hash value, because it is just checking with the name. Now name should be equal, and this will guarantee the same hash value. Okay, so we don't want to keep it like that, and we want to add the id as well. Okay, so it will be different since the id is 10, and now again running, the uh, result will be same. In this case the hash values will be same. Okay, so now a very important note regarding hashable. If the two instances are same, the objects basically, if the two objects are same, then their hash value is always same. This is guaranteed. But the vice versa is false. Means if the hash values are same, it is not necessary that the objects are same. So you get it why this line is. The first line I'm assuming you get it, because since we are using this hash function and we are making use of the name and id hash values, so it is assuring that if the objects properties and ids, basically the properties of the objects are same, and if we have defined this in the function, then it will guarantee the same hash value which it is doing. So this line is perfectly fine. Now comes the second part. So it means that, let us suppose I am using I'm making different objects. Let's say I change this into id and I run the project, and you can see that we have different hash values. So hash values are determined dynamically. So there might be a possibility, which is actually very rare, but there might be a possibility that the two hash values can be same for s1 and s2, although it is 0.001% that this possibility can be true, since dynamically both of the objects are assigned to the same hash value. But it can be possible. So this line states exactly the same thing, that vice versa is false, and the hash, if the hash values are same, means if these are same, so it is not guaranteed that the objects are same, s1 and s2. So we have to take the first. Obviously, if the two objects are same, then we can say that the hash values are same. So better to use the double equals to operator in that case, to check the equality of the operators rather than a hash value. So you should avoid this hash thing as far as possible, but obviously you can use it, since I'm again saying that it's very super rare that the two hash values can be same for the two different objects. But yeah, they can be, there is a possibility. So it's up to you guys. You can use hash values, it can be different. It is actually different every time, if I will run this project for thousands of time. But yeah, who knows that whether dynamically the same hash value is assigned to two different objects. So it's better to use equals to operator because it guarantees the equality of the objects, and this can deceive you for a moment, maybe for a single time in lakh or crores of a time. So again, it's your choice, but we can make use of hash values like this. So hashable protocol is all about the hash values, and obviously it is conforming to equatable, so we can obviously write this double equals to operator and we can perform the equality check in that case. So this is all about hashable, equatable and comparable, and all these things can also be used with structs and it will yield the same thing. Okay, I'm trying to write struct here. My playground might be hanged, it's not responding, but overall you got the idea. If I just rename that to struct, then also it will work. Let me just wait for a second and check for the structs as well. Okay, now it's working. Struct, and obviously if we are using struct, then we have to make that as var, since it's a value type and I am modifying the properties, and these should be var always. Okay, and yes, it will be working same for the structs, and I'm going to make the objects same, and let's check the hash values, and yes, they are the same. So it doesn't matter it's a class or a struct. So all these protocols, equatable, comparable and hashable, will work for structs as well, or enums as well. Okay, this is all about the three important protocols which we can use to modify our code, and we can use to compare the two different objects of different of our custom class or structure. So thank you so much for watching, and do leave your comments if you find anything which is not you don't catch that thing, or maybe there is improvement if you want in that. Okay, so please do watch and do let me know. Thank you so much.